So we are going to talk about extreme programming. Now, how many of you are actually in software development? Related to software development? Great, lots of hands. So how many of you are actually enjoying software development? Be honest. Like, I'm a software developer for 20 years. Very few hands. So let's see if we can make it interesting. So we are here to make software development great again. You know? Let's see if we can make it or not. So I am not trying to be the Donald Trump here, but hopefully we'll have some insight. So a few things about me, I think I told a lot. So in short, I'm just a digital nomad. I love to travel and work. And that actually creates a problem with XP that I'm going to talk. So I'll talk it during the disadvantages, like why XP doesn't work for me. So what is actually extreme programming? How many of you actually heard about extreme programming? Very few hands. So that's surprising. We are into software development, but we haven't heard about extreme programming. So it's not actually surprising because in general practice, only 10% of the Agile teams are following extreme programming. And as it suggests, like, have you heard about extreme games? Like extreme sports, like bungee jumping, skydiving, So these are very highly intense games. Usually we don't play. We are okay with football, cricket, table tennis, maybe pools, good. Extreme sports requires, extreme level of enthusiasm, courage, and lots of risk involved. Same goes for extreme programming. We'll see. So as per Ron Jeffries, one of my favorite software architects, he says that extreme programming is a discipline. It's not a framework. It's not a tool. It's a set of practices that helps us to actually make the software development in a better way. Now, most of us who knows about Agile, or say, in some cases, we are following Scrum or other framework, we know what is this all about. The funny thing is, like, extreme programming actually came before Agile. And lots of the things that Agile Manifesto talks about are actually inspired from these practices. So any ideas, like how old is extreme programming? You are close. How old is Agile Manifesto? Exactly 22 years. So this month, I think they have completed 22 years. Extreme programming is actually 26 years. So extreme programming is completing 26 years in March 6th, if I'm not wrong. So March 6th is going to complete 26 years. So that means extreme programming came even before the Agile Manifesto was, formulated. And the funny thing is, like, the guys who worked on extreme programming are actually the signatories of Agile Manifesto. So what extreme programming says and how it's different. So if you can see the diagram, it's almost similar like what we have seen in Scrum. So what extreme programming believes is that let's focus on requirements in a simplified format. We call it user stories. So if you heard about user stories from Scrum or Agile training, this is the place where it was actually born. So user stories were part of extreme programming practices, and they believe few things. That, okay, requirements are there, now let's plan the release first. And usually, we do the release planning for quarter. So product team or customers will be planning for a quarter. Now that comes your safe practice, PI planning. So we do release planning, usually 3 months, you can do it 1 month. And from the release plan, we know we want to do it in a smaller chunks, the iteration. Usually it's 1 week or 2 weeks, and we build it. Is it visible from that side? Because I can actually see very less. Sorry for the quality of the picture. So then what do we do? The main thing, like if you are asking me, I'm been practicing Scrum for the last 17 years. The problem I see in Scrum is that as a software developer, we don't have enough time to actually run those spikes. Like we have issues, we don't know about a certain, technical difficulties or some R&D work is needed. Usually we don't get time for the spikes. Because as per our definition, we should be delivering something valuable at the end of the iteration. And most of the time, this spike word even doesn't, exist in Scrum world. So I've been following Scrum and trying to apply Scrum in our part of the world. When I say our part of the world, like in Bangladesh. And I have seen lots of problem. And the problem is that teams are not comfortable. They're doing because it's a process. We are forcing them to actually follow that process, and they are actually not enjoying it. So recently, I have decided to actually move from Scrum to complete to eXtreme programming. And what we are actually trying to do is that, since we have to do lots of spikes, whether it's an architectural spike or user story spikes, to understand the requirement better, to understand how we can actually do things better, it helps the team. So it's more about giving the team, confident what they're actually doing. So once we go into iteration level, we do some work, and in eXtreme programming, one of the reasons that I like is that all the features that we are doing are driven by acceptance testing. So that means without your acceptance criteria, we are not actually creating any user stories. And these acceptance criteria are approved by the customer. And once the customer approves it, then we are releasing it. Now, as the Dai was mentioning, at the very beginning, like we developers do something, we know there's a problem, and we give it to our QA team. Like, what is the quality assurance ratio in Nepal, usually in a software development team? I heard during my CSD classes, 1:2 or 1:3. So that means if you have, say, 2 or 3 developers, you will have 1 QA. In my team, the ratio is 1:8. Now you can say that's quite inhuman for QA engineers, right? Like one QA has to work with 8 engineers. My target is to actually get it to a level where I can actually have 1 QA engineer for 15 engineers. Impossible, right? So I'm not going to be a good engineering manager or lead. I agree. So I'll come to that, like how I'm going to do that. So in XP, what we do is that when XP came, Ken Beck, Ron Jeffries, and Ward Cunningham, they actually started in 1996 in Chrysler, just when we started doing object-oriented programming and analysis. And then they published a book in 1999 called eXtreme Programming. And that's where everyone knew about it. But they actually started practicing. Now, if you look at the whole history of software development, Waterfall came in 1970. In 1980, we had something called spiral model that came to picture. And that actually inspired a lot of things, especially in my practice, what I have seen that spiral model inspired this whole agile thing, iterative and incremental development. And in 1995, our favorite Scrum came into picture. 1996, this eXtreme programming. And in 2001, we had this Agile manifesto. So an official Scrum guide, I think if I'm not wrong, came to publication. The first official Scrum guide came in year 2010. Because I did my CSM, Certified Scrum Master training in 2006, and that time we didn't have any official guide. So we used to write, read the books provided by the trainer. Now, what are the values of eXtreme programming? What we are actually trying to do? So eXtreme programming says that focus on communication. We talked about emotional intelligence. We talked about the human side of agility. In my 20 years experience, the worst experience I had is the communication. For some reason, We software engineers are not engineered or built for communication. Like, right now I have a team of almost 40 engineers. So we work for a US startup, and our engineering team is actually based in Bangladesh. The only complaint I got from my product team and my management team in US is that we are not good at communication. Just to give an example, the day before yesterday, I had a call. Like usually, we have a midnight call with the product team. I went to the call, and all of a sudden, my project manager was telling something. I was like, "What? Where did this coming from?" Like, I talked with the team in the morning. We are aligned. This is happening. We have a major release on 7th of March, and this is the core feature going out. And you are telling me it's not going out? What happened in last 2 hours that I am not aware of something happened. And we are constantly chatting. Even before I'm coming to the stage, I was actually chatting with my team. So the problem is that they didn't feel like to communicate with me. Not at all. So extreme programming will actually focus on that you have to communicate, whether it's with the engineers, whether with your customers, you have to have a proper communication channel. Simplicity. Extreme programming, the reason I like extreme programming is that we believe in one principle. Have you heard about KISS? Not that case, it's called keep it simple and stupid. So it's the programmers, we follow it. Extreme programming says that keep it simple. You don't have to build something amazingly complex or amazingly scalable on day one. Do it in a simplest approach, then add complexity. But we engineers, we have this, as Dai was telling, I agree with Dai, when you are a fresh graduate, you are overly excited to do things. Like you are asked to do 10 things, you will be doing 10 or 15 or 20 things. So it happens. So what we try to do, we try to over-engineer. Extreme programming says, keep it simple. We love feedback. Extreme programming focuses on feedback. Even, in fact, the Agile feedback cycle was defined by extreme programming. We'll actually see how quickly we receive feedback in extreme programming. Courage and respect. Of course, we have to have courage to say no. Most of the time, since you guys are doing software development, and I know about Nepal industry, most of us are actually either product driven company or outsourcing. And in both cases, there's a problem. The problem is that it's a top-down approach. You have to do something that your customer is asking for, or your sales team has already agreed to the customer. Like, okay, this is this 1-year-long project, this budget, this many resources. And we are fixed to it. And we have no other choice but follow the instruction. Like, tomorrow is the deadline, you have to do it. You can't say no. So extreme programming says that you must have courage to say these things. If something doesn't work, you have to say that. And since we are working in an environment where everyone is together, our customer, our engineers, architects, we must have respect for each other. Now, as I said, extreme programming is a discipline. It's not a framework that you have to follow every part, like this has to be there, or this roles has to be there. There's nothing like that. The basic difference between extreme programming and Scrum is that it doesn't talk about those accountabilities. It assumes that accountabilities belongs to the whole team. So you decide who does what. The only thing we need in extreme programming, we call it the whole team approach, where our customers are also part of the team. That's it. Now, how you composite the team, that's up to you. So there are few rules, and these are actually self-explanatory. So let me go through some quick rules. We write user stories. That helps our planning. We do release planning. We do small frequent releases. We do things in iteration, and iteration planning happens at the beginning of each sprint or iteration. We do believe that team works together. So that's another problem, especially for me. Set a sustainable pace, stand-up meeting every day, velocities means calculated, move people around, and fix the problem. If there is a problem, fix it. The interesting part is actually on coding and testing part. In coding, we say that customer is also available. Now, what is the relationship with coding and customers? Like, can we bring customers when we are actually coding? Usually it happens. Not. The reason is that we believe that customer has to be present whenever team is working. So coding doesn't mean like we are writing some code and actually customer is looking at it. It's presence that matters. Code must be written in some standards, and code must be written as a pair. So there is strict rule in eXtreme programming. There should not be any production code written by one programmer. It has to be a pair. And let me tell you the real experience what I had last week. One of our features was supposed to go, as I'm the head of engineering, so usually we agree on the dates, and in our case, the dates come from engineers, not me. So we all agreed. On the release date, like something went out, so we published the release doc, and it, I even didn't look at the release doc. As I'm traveling, I know I have a full trust on my team. My CPO called me and like, Mizan, what's happening with this feature? Why did it go out? It's like, what? It's supposed to go out. And then it's like, no, it's not, it didn't go out. So I asked my project manager, what happened? And he was like, oh, the guy is sick. I was like, the guy is sick? And he's sick out, he's out for 3 days. So what happened to other resources? Oh, he was only working on that part, so nobody wanted to actually take responsibility of that. And the funny thing is, like, it was a very important feature. It's one of our stadiums that we support. And there was supposed to a press release, a media release, a news supposed to happen with that feature. Everything planned. And nobody, including my project managers, thought that, okay, it should be important to tell me that it's not coming. Now, if I had a person who's actually working together with that programmer, maybe I had a less risk, because if one person is out sick, another person is actually there. So eXtreme programming understood this 26 years back. Unfortunately, my project managers or me, we didn't understand that. And this is the biggest problem. For testing, eXtreme programming is very particular about testing. Now, how many of you actually practice the test-first development approach? Not TDD, test-first development. You write the test first, then you write the actual code. How many of you practice that? You are in a good company, I see only one hand in the whole room. If it was in Bangladesh, I'm pretty sure like no hand have raised. Because I don't blame the engineers. It's the culture. Because when we're actually doing this agile thing, the only thing comes to our mind is like agile means two things. One is faster delivery. Forget about quality, is the faster delivery. And second, doing more thing with less programmers. In Bangladesh especially, we believe that agile means doing more with less resources. So that's actually being the problem. Now, XP is a very simple thing. We have lots of practices. We'll be talking few of them. So there are 12 practices we call in XP. The code is actually a few things. We'll be actually going through that. So for us, the feedback in XP is really important. Say, we are doing this. Release planning, we are doing for months. We have iteration planning for weeks. We are doing acceptance testing, which actually takes a day maximum. We do stand-up, which is, once a day. We do pair programming, which gives us feedback immediately, and it usually we do it, in such a way that we get the feedback instantly. So it's a pair programming in seconds. We do unit testing, which actually gives us feedback instantly. So these are the feedback cycle that we actually use for eXtreme programming. Now, if you look at this code ownership part, extreme programming believes that the whole team owns the code, not a single person. Typically, when we develop code, uh, usually we assign one ticket or one feature to one engineer. Now, how many of you actually do pair programming in real life in your organization? No pair programming? Then how do you actually share the experience or understand the code that other people are doing? Code review. And how do you guys do code review? LGTM. Have you heard about LGTM? Look good to me. Right? So that's actually, even if I open my code review channel right now here, my company one, all I see is LGTM, LGTM, LGTM. No feedback, nothing. You see, it looks good to me. And that particular person doesn't have any idea why he wrote that code. Right? He just checks the syntax, maybe some mistakes in the code, especially mostly naming convention, why the function is too big. That's it. He has no idea that what was the expected behavior from this code. And he just says that, it looks good to me. And it went to production, and it doesn't work that way. So that's the problem. So code review is not bad, but again, if we can have a pair who are working together, who are actually sharing the knowledge, who are checking each other code, that might improve the situation by a big margin. So typically, in extreme programming, we have these user stories with acceptance criteria, and we already know that, like as a I1, so that is a very commonly used in Scrum and Agile trainings, but these are all coming from extreme programming. We call it 3Ws, who, what, and why. So we write user stories like that. But these are not enough to understand what is the requirement. So we define the acceptance criteria. We discuss, we call it 3Cs, card, conversation, and confirmation. So we, based on this card or the user story, we have a pretty detailed conversation among the engineers and the product team. And then we have a confirmation, which are the acceptance criteria. And once we have done the acceptance criteria, this acceptance criteria will drive the development and also the approval of the completed task. So this is important. And usually, one of the core practices of extreme programming is, we call it CRC card, which is, since it's based on object-oriented programming, so we have class, responsibilities, and collaborators. We call it, in short, CRC card. So we try to keep the design very simple. We don't go for a high-level architectural design or something like that. We do it very simple way. Or one of the simple way to do a system design is CRC card. So this is actually one of the practice extreme programming's belief. Now come to the biggest thing, that's why I like extreme programming, is this one, TDD, test-driven development. In fact, I would say it's actually TFD, test first development. So what is the difference between test first development and TDD? So TDD can be a bigger umbrella, like says BDD, ATDD. So these all fall under the umbrella of test-driven development. But when we say test first development, we are focusing on particularly unit testing. So how many of you write unit test when developing software? Good, 3, 4 hands, not bad. So, see, you are doing software development. I believe 70% of you are working in a software development projects, and maybe out of that 50% are software engineers. And you are not practicing test first development or writing unit test. Why not? Any reason? Project manager nahi manenge. Like it takes time, so we are not going to do it. Now, what are you trying to solve by not giving enough time for these quality things? We're trying to make our customer happy, right? Now, Agile says, make customer happy with early and useful delivery of software. not a buggy software. Like, let me give you an example. We release once every week, so that's our weekly release cycle. And what we used to have is that once we have done the release, next day, we are actually doing hot fixes. There was a case like it, one day we had 3 hot fixes. After release, after 2-3 hours, we did 3 hot fixes. So I sat with my team, I said that, guys, I know we are since we work in a startup, we have lots of pressure to deliver things. So I told them, like, can we improve this? I don't want to hear the term hotfix anymore. Like, if we are releasing properly. And I don't blame those guys, because once we have our build ready, so we have, kind of like desktop app, we have web app, mobile app, the whole regression cycle takes roughly around 12 hours to complete by the team, by the QA team. Now, you release something in production, do you want to wait 12 hours to find that there is a problem? And the problem is that we are fully manual. Like, QA team does and test things manually. Now, that's a problem. Since we are not practicing test-driven development, and the only excuse my team gives me is that we don't have time. We don't have time. We know it's very good, but we can't actually get it done. So what we try to do in test-driven development, we call it red-green refactor. It's called TDD mantra. We write test case that fails, which is red. Then we make it enough, we write enough code to make it green. Then we do refactor. It's a continuous cycle. It goes on and on. And what it helps us instantly to see what's happening. So when you're writing test-driven development, you go to command line, build your code, and you see the results instantly, in seconds. That, okay, is there any problem? So if the test cases are passing, how many lines of code are covered with my test cases? Am I missing something? The feedback is instant. So if something is broken, say I have one failure or one error, I should not be committing that code. I'll be fixing that and then committing. Like, did it happen with you guys that you wrote something that broke something else that was not supposed to? Like, one developer changed something, and it has nothing related to some other features, but all of a sudden, it stopped working. It happens, right? The reason it happens because we don't practice these things. If it's a test-driven development approach and we have these test cases that covers most of our codes, we have an instant feedback whether our code changes working or not. Now, there can be a good excuse, like, since I'm involved with community, one of the feedback I received was interesting. Like, one of the guys wrote a simple JavaScript plugin for React, and he told me, bhai, like, you guys call Dai in Bangladesh, we call it bhai, the senior guys. And he was like, bhai, that plugin took 1 week to build. But with test-driven development, it actually took me 2 months. The plugin was 120 lines. The test cases files was actually around 11,000 lines. So it's like you are writing more codes for your test than actually you are writing for implementation. Now think in real life. Is it possible for your product manager or your sales team to predict that and give you time to do that? Usually we don't have that. And what we do, since it's not required, we just bypass it. Like, quality is not our problem. We have a quality assurance team to find all the garbages. Right? So that's the problem. And then one of the key part we do in XP is the acceptance testing, or we say customer test. So UAT is done frequently. So for our product, we have UAT process. And the funny thing is there, our product teams don't do UAT. Like, we keep the tickets on UAT, like, okay, guys, I need your acceptance. Check, make sure it works or not. When we have some emergency deadline, they will just move the tickets to ready for production. And I was like, what? Did you guys test it? I was like, no. Then we'll see. And it happened is that since we have stadiums as software users. It went to stadium, and all of a sudden we got getting, communication in our support channel like, oh, something is not working. And I was like, why? Oh, we forgot to test it. So we released the software without testing. So this happens, and these are common thing. So what eXtreme programming says that focus on user acceptance testing, and we have a very specific discipline for that. We call it ATDD, acceptance test driven development, and we try to automate the whole thing. It's the same red, green, recycle, TDD cycle, but in a different way. I hope most of you guys use Selenium here, QA people, for automation. Selenium can be a part of it. There are some other tools as well, but we use mainly for UI-based testing, we use Selenium or APM to make sure that acceptance test driven development are done. Now, what we are trying to solve here with eXtreme programming, if you look at this, if you look at the left picture, this is actually what we are doing at this moment. Like we'll write very less unit test or no unit test, so it actually makes not a cone shape like, it looks like a bowl, not even cone, because hardly developers write unit tests. So say unit test is not there. So units are not working properly, we don't know. So what we do? We do more acceptance tests. So that means we are writing more or doing manual works to find the integration part or acceptance is working. Then we try to automate the GUI test or UI testing. And on top of that, we have a very big manual testing. So that's why you need 1:2 or 1:3. Or maybe 1:1, like one engineer, one QA. Super efficient, right? So that's the problem. Yeah, it's nothing bad, but it actually requires more time and effort. Now, when you are releasing frequently, do you have that time? Say, you guys release say once a week or once a day, right? Say Google, how many releases they have every day? Any idea? Roughly around 12,000. And if Google engineers has to do the regression manually with their services, we are doomed, right? It's not humanly possible. Because the time you're doing regression, another release has been happened. So what we do? We move to this side. We change the shape from cone to pyramid. So what we do? We do unit test. Now, who writes the unit test? Can you tell me? QS? Have you heard QA writing unit tests? I heard it in a conference in Singapore, and I was shocked, like, why? And that's like, yeah, in our company, we have QS who writes unit tests. I said, wow. That's something maybe, we should tell these guys who develop the TDD practices, like, do you know QS can also write unit tests? So unit tests should be written by your developers, your engineers. So they write unit tests, and if you have a good coverage, like say all of our codes are covered with unit tests, then your component or integration test will be lesser because you know that particular unit works. So if you, like A works, B works, so A, B together will work. You don't have to maybe try all the combination, whether A plus B or A minus B works or not, because since A works and B works, there is a high chance that A-B integration will also work. So it reduces the work. And since you have a more better understanding on integration test, you will need very less UI testing as well. And that will also reduce your manual testing effort. So the reason I have this 1:8 or 1:7, ratio now, because we are focusing on that, on fully automated test scenarios. So XP focuses on that. And it is very high on return on investment. And we follow this simple practice like coding standards. So all teams must have a coding standard and certain way of following the codes. So you just can't go and write the way you want to write a code. So typically we use tools like this. So these are the latest tools. I'm not sure if you guys have heard about it. So in my organization, we use SonarCube. So it's a tool that inspect your codes, and it can do lots of things. Like it can find code smells, your bugs, security threats, everything. It's automated. And it's also kind of AI-driven, not ChatGPT, but it actually does based on some rules, and it automatically updates rules based on the practices across the repositories. So this is a very nice tool that we actually use, and it tells you everything. From each commit to your project, you can actually find the insight. So these are the coding standards we talked about. And then the most interesting part of XP is pair programming. Like you guys play cricket here, right? We also play cricket. I talked about something very important. Like you need 1 run in 6 ball. You don't come and try to hit 6. I was smiling that time because unless you're Saqib Al Hasan, Saqib Al Hasan doesn't care like whether team needs, like it's the last wicket, I need 1 run in 6 balls. He will try to hit 6. And he will get out and we'll lose the match. It happened many times. And if we ask him like, why did you do that? It was not necessary. And it's like, it's my playing style. Take it or leave it. And unfortunately, we don't have any replacement of him, so we have to be with them. So the problem is that when you have such irresponsible people who are actually doesn't care about what's happening, they will do things on their own, you need an extra pair of eyes. So a pair programming, like here, this picture, they're doing a rally, right? Why do you need 2 people over there? 1 is enough, right? 1 driver. Like Formula 1, one of my favorite sports, they have only 1 driver. And that's the highest, most speed-centric race in motor racing. So Formula 1 is the most expensive and fast-paced race. But this is rally. Why do we need 2 drivers over here, like 2 people? Like these guys, they are not running or driving in a road. They are running in desert or say forest or villages. Their roads are not very well marked. So someone needs to guide you. Like you need to turn left, you need to turn right, there's a slope. You need to reduce speed. So this guy with this chart actually knows where to do what. So this is the navigator. And together they are achieving same thing, which is winning for the team. Now, if you go and tell your product manager or management that, okay, for each feature, we'll need 2 programmers, not 1. Yeah, it's doable by 1, but it will need 2 programmers. So that means your cost automatically doubled. Will you accept it? No. And that's what happens. Like, we know pair programming are good, but that's why you don't follow pair programming, because it's costly. So my suggestion, do pair programming. It actually reduces your code review time a lot, and it gives you instant feedback. Your quality of the code goes up if done properly. Same goes for TDD. If done properly, it can improve a lot. But what we do in TDD, just to show that our code coverage or test coverage is 100% or higher, we try to do some silly things. Like, where we are supposed to do lots of testing, we just know the well-known case. Like, I know, if I'm building a calculator, what will happen? Say I have 2 input in the waveform, A and B. I know it will be always integer, right? So I'll assume it's an integer and it works. And I give it to QA like, okay, now you can test. And QA tried with this string, email address, special sign, and it breaks. And one of my companies, my CTO used to call Mizan system crash. Like, what? System crashed? It's a website. How can it crash? It's a web app, Usually when we say crash, it's like backend already gone. So usually when they get any error, they say it's crashed. So I was surprised, like, why is saying crashed? I checked the backend log, nothing I can see. It's okay. So then I found, like, okay, what we are trying to do? And she was like, yeah, I tried to put a space, then number. And it showed me, like, page not found. I was like, that's not crash. For her, that's a crash. So the problem is that developers always try to go with the happy path. I know it works. And the favorite term we have is that it works in my computer. right? But it doesn't work in your computer, it's your problem, not mine. So that's the problem, that if you do try, do things like this, I know 1 plus 1 will be always 2, and I tested it. Now what happens with 1 plus 1.5? Oh, it's integer and floating mixed. System throwing error. I didn't notice that. I thought it's always integer. So we try to cover up our weaknesses, or we try to proxy our efforts by writing codes that is not enough, especially in test-driven development. So that's why I said test-first development. Because if you're writing test after the development, your intention will be always try to get the coverage high, not the quality. Because you have to show your project managers that, okay, the code coverage is high, nothing else. So that's the problem. So same for the pair programming. If you are there just to show them, yeah, we are doing pair programming, that's a problem. You need to do it properly. So if I am doing a pair programming and say my navigator, this is the most famous model, driver and navigator, one person code, another person checks. I am writing the code and another person is busy in Facebook, in his phone. What's the purpose of doing it actually? So we should not be doing that. And then the last thing, we talked about this, consistency thing. Team should always, work in a constant pace. This is what we mean. Developer should not work more than 40 hours per week. And when it's a 40 hours, that's 26 years back thing, like not recent one. And they thought like developers should not be doing overtime. Not at all. So Monday to Friday, 40 hours per week. Now that includes all your non-productive things as well. 40 hours of week doesn't mean 40 hours coding. So typically my effective hours are 40% or 30%. Like I don't code still, but yeah, I do architectural review. I do discussion with team related to architecture, scalability, availability, necessary practices. I consider those as productive hours. I can give roughly around 2 to 3 hours every day, which I can count as a productive hour. But yeah, I spend 12, 13 hours working. Most of the time, unproductive things. Like talking with my product team, my CTO, my project managers, and since I am the kind of like country manager of the Bangladesh team, I have to do everything. Like if office needs something, it has to be done by me. Like people will ping me like, okay, we need this. Okay, fine. We are trying to get it. So that's unproductive. Everything accumulates to 40 hours. So you should not push your engineers to work more than 40 hours. And in many countries, it actually became 32 hours now, especially in Norway, Sweden. We are also, like in my team in Bangladesh, we are also trying to think we should be going 32 hours a week because it's really a problematic thing. Like 40 hours a week, a lot, and especially in Dhaka traffic. So if you want to know about more extreme programming, as I said, it's a very nice thing. We have the website. Everything is over there. It's little descriptive, not quite appealing, but some good information. We have this book you can read where it all started, The Extreme Programming by Ken Beck. And as I said, this is an extreme sport, so that's why I kept it later. Extreme sports need lots of courage. It's risk involved. So extreme programming also comes with this risk. The cost is immediately went up with pair programming, with TDD. It will slow down your development. You can't have customer on premise every day. So there are some challenges of extreme programming, and that's the reason only 10% of the software development teams follows extreme programming. But over the years, the experience I had, the common problem we face as a software engineers, we want to work. We don't want to, follow, like, say, product owner, scrum master, or the roles or accountabilities. Our job is to write code. Like, for me, I write code for the last 24 years. I still love writing code. So when I don't have work, like, in my current job, it doesn't allow me to write code because I don't need. I have engineers, almost like 40 engineers. So what I do, I solve problems in HackerRank. When there's a contest, I go there and solve problem because I have to do that. I enjoy writing codes. I love building things. So if you're doing that, focus on that. So extreme programming, focus on that part. You don't have to worry about these ceremonies, these artifacts. It comes automatically. But again, the disadvantages, cost involved. It's a discipline. And again, another thing that stopped me from joining army, like it's a childhood dream for all Bangladeshi guys. Like when we are kid, either we want to be a pilot or we want to go to army. Like joining army is a very decent option. So I applied for army, I got selected, got the invitation letter, like, okay, you have a test. Then I thought like, is it for me? Can I wake up every day 5 a.m.? I can take a bullet for my country, fine, but I can't, waste my sleep. Like 5 a.m., no go. So then I decided, okay, let's do something else. So become a software engineer. So we hate disciplines. As a software engineers, we hate disciplines. So when you're talking about this test-driven development, extreme programming, it requires discipline. So if you want to make things better, you have to be disciplined, and extreme programming can help you. It's not a magic lamp that will fix everything, but if you are a disciplined programmer and love doing things, maybe it is for you. So thanks a lot. If you have any question, I will take a few questions. We have time, right?
We can do it in a network.
We can do in the network section. So, Dai, you should show the cartoon, you should keep it open. So that's the extreme programming, joke. So I hope you guys get it. So what you guys should do, start practicing. If not extreme programming, take some practice like test-driven development, pair programming, at least in certain circle. And I hope all the best. Thank you, guys.